And let's have a look at an exam style question to finish. So I've given you the weight of an object on Earth. It's transported to the moon on a rocket. Quick revision of units. I want the units of mass and the units of weight. Now, also I want to know if mass is a scalar or a vector, and if weight is a scalar or a vector. And then finally, we want the weight of the object on the moon. And I've said g is 9.8 on Earth and about 1.7 on the moon. So you'll see, although the mass is going to stay the same, but the weight is going to be different. Remember, we can use this equation to link between weight and mass, and you will be doing that a lot in the exam, so try and memorize that formula. So have a crack at that question now. It's a very quick one. If you're struggling with the last one, don't worry, and I'll go through the answer for it. But hopefully if you have a think about the previous pages I've just shown you, you should be able to figure out A and B. Have a quick go at that question now, and I'll go through the answers in a second. Okay, hopefully you've had a chance to have a look at that question, and let's have a go through the answer. So the units of mass and weight. Mass is in kilograms. Yeah. A mass balance weighs kilograms. The scales scales show kilograms as well. Weight is a force, and that means it's in newtons. Okay, so a distinct difference. Mass is how much stuff there is in something. Weight is the force with which it's pulled towards the surface of the Earth. So note that this is a force. Now decide if mass and weight are vectors or scalars. Well, weight is a force, and forces are vectors. Okay. So weight is a vector. That means it's got both a size and a direction. The direction of weight is always towards the center of the Earth, so we kind of see it as being downwards most of the time. Mass is a scalar. It doesn't have direction. If you have a mass of 100 kilograms, it doesn't point anywhere. It just tells you about how much stuff is in something, so it's got no concept of direction. Okay, and what is the weight of the object on the moon? Okay, so remember our equation, W equals mg. So we know the weight of this object on the Earth, and we know g on the Earth, the acceleration due to gravity, so we should be able to figure out the mass, shouldn't we? The mass is going to be the weight over g. If we rearrange this formula, so the weight is going to be the 50 newtons divided by the 9.8. Which gives us 5.10 kilograms. Okay, so that is the mass of this object. And we want to know what the weight of it is on the moon. So the weight on the moon is going to be the mass times g on the moon. We've said the mass is 5.10 kilograms. That mass is the same everywhere, so we can use it on the moon and we can use it on the Earth. It's going to be the same value. And g on the moon is 1.7. So if I do that multiplication, I get 8.67 newtons. Okay, so that would be its weight on the moon. You can see it's considerably lower, isn't it? It's less than a fifth of the weight it was on Earth. So really important that you understand the difference between weight and mass, and just remember, of all things, remember this equation. Okay, in principle, because of this equation, all objects should fall to Earth at the same rate. So a heavier object shouldn't fall to Earth faster than a light object, even though we kind of think it will. Unfortunately, this is kind of ruined by air resistance. But the point is, if you went to the moon where there's no atmosphere and therefore no air resistance, and you dropped a feather and you dropped a rock, they were from the same height, they would hit the floor at the same time. Okay, it is a bit ruined on Earth by air resistance because lighter objects tend to produce proportionally more air resistance. Okay, but in principle, with no atmosphere, they would land at the same rate. Okay, so that's kind of an interesting effect of this equation. But of all things, try and remember that equation. I don't think it's given to you in the formula book, so worth memorizing. Obviously not a particularly difficult one to memorize. And that's everything for this lesson, just a quick warm-up for mechanics. We'll get more into it next time when we do kinematics. This is where we look at accelerations and velocities, distances, and how we link all those things together with a whole bunch of equations. So for now, have a look at the Solve4x website if you'd like to, and you'd like to go over anything for the mechanics. Even though this is quite a simple topic, we still put together some questions for you to have a look at. There's not many questions, to be honest, which directly assess this material. It's more the stuff you need to know to answer harder questions as well. So you might get the odd mark here and there for the stuff in this lesson. But most of the marks are for knowing about kinematics, which is accelerations and things, and knowing about forces, which we'll look at later. So I'll see you next time for the next videos on kinematics. Thanks very much for watching.